ECE461 challenge assignment demonstration, MSP432, plug it in, debug mode. A lot of these codes are written in driver library, TI, provided by TI, so I'll walk you through it while I'm debugging in debug mode. So first step, stop watchdog timer. Initialize the clock setup. Within the clock setup, DCO is set to 1.5 megahertz. I didn't use the MC clock or the HSM clock. I just have it here as a future reference. A clock is set to use REFO clock, which is 32 kilohertz, and same thing with the SM clock. Next is watchdog timer setup. Watchdog timer is set to in watchdog timer mode and not in the interrupt timer mode. So it uses a clock as a source, which is at 32 kilohertz, and it's going to count up to 32,000, which makes it exactly 1 second before the system resets itself. Timer 32 setup. Timer 32, I have two timers, a 0 and 1. The first timer is set up to go off, set an interrupt every 1 minute. It is using a DCO clock source, which is a 1.5 megahertz. So I'm counting up to 90,000 right here. And this is the timer that I use to initialize the flashing operation every minute. And this is a 1 second timer setup. So the setup to count to 1.5 million. And this is the timer that I use to for 1 second LED blink. So you turn on the LED, you turn this timer on, and then within the interrupt, a second later, it turns off the LED. So timer A setup, this is the timer that I use to reset the watchdog timer. So that happens, it's running on A clock, which is at 32 kilohertz. It counts up to 1685. So it happens every half a second to reset the watchdog, to clear the watchdog timer. If this timer stops, then the system resets. Push button, so pretty much to initialize the GPIO pin to input and pull up resistor. You can see that. Flash setup, this is to unprotect the whole entire bank 1 of the flash memory, so I can write to it. Enable the interrupt, set the LED pin to output. So this is going to turn on the red LED to indicate systems just got rebooted or reset, and I'm going to set the timer 32 to turn it off after a second. Start timer 32.0. This is our 1 minute timer for the initialization of the flashing code. Watchdog timer, timer A0, which is used to reset watchdog timer, flash operation. So the flash is set up to write a 4K block every loop. So I have a data that's 1024 data array that's 1024 member. Each member is 4 bytes, so it's 4K data block. Here's a pointer to the data, address pointer, which will give the initial address of the flash memory. Here I initialize the data in the data array block to have consecutive numbers. So in this case from 0 to 1024. Let me skip this. And here's a write to flash flag. So if that's 1, we write to the flash. If that's 0, we don't. So you can, while going to the while loop, we check for this. If it's 0, we don't skip it. If it's 1, we go into it. So in this case, it's 1. We perform the erase first. This will erase all the unprotected section on the flash memory, which will be bank 1 that I just did. Gave the beginning address to the address pointer. And while the address pointer does not point to the end of the bank 1 address, we perform the flash. So in this function, which is a driver function, library function, we give it a pointer to the data that we want to write, the address of the beginning of the flash memory, and the length. So in this case, I'm writing 4K of data, 4 kilobytes of data from here, the data pointer, to the address here, beginning address. In this code, we trap the program if the write fails, and we disable the timer A0, which will cause the watchdog timer to reset if that fails. But I've never seen it happen yet. So over here, everything's got written. So we increment whatever's in the data buffer by 1, so I don't write the same data over and over again. And here is to increase the data flash memory address to the next block, which is the next 4K block. So here we can see that we should have already written the first block. Here's the memory. You see it's a consecutive number in the flash memory all the way up to 21,000, which is a 4K block. FFF means it's not written yet. Number means it's written. So let's run to the end and see if it reads all of them. Come on. There it is. So at 3 FFFF, you see this is the end of the memory and everything's got written, so we're all good. And let's keep on, and we reset the flag to 0, so that means we're done with the operation, and now we just have to wait until the interrupt, 1 minute interrupt, set this back to 1 again to go back and flash again. And we turn on the green LED to indicate that it's done flashing, and set the timer to 1 second, and we're good. So within the interrupt routine for the 1 minute interrupt flash operation, we have, this is the 1 minute timer interrupt routine. We set the flash to 1, so it will actually flash again. And in the LED 1 second timer, we turn off all the LEDs. So when this happens, which is 1 second after you turn on the LED, it will turn off the LED. And in this interrupt routine, which is the watchdog timer reset, happens every half a second. We check for the GPIO pin, which is the button. If it's high, which is not pressed, you clear the timer. If it's not high, which you press the button, you don't clear the timer, which will cause a system reset. So let's see it in operation. So if I press the button, it should reset the system. Red means it's resetting, and flash, done flashed. So let's wait for a minute. It should happen within a minute. Anytime now. Takes forever. Oh, there it is, a minute. So if I press it again, it will actually reset the system. Reset, and it should happen again. There it is, done flashing. So it will actually flash at the beginning, and it will wait a minute until it do the next flashing cycle. So that's the end of the demonstration. Thank you very much. Have a nice day.